minutes if this were a real problem. Actually, if this were a real project, we want to set it up on one point. So now it's collecting readings 1 per second. 5, 6, 7, 8, 9. And I have a root mean square error of about 6 feet horizontally and about 11 feet vertically. Right, it was showing me that. So it also allows you to set a base ID. So you can give this base a number between 0 and 4,000 usually that identifies this base. So if you're on a big construction site where you might have different companies using RTK at the same time, you want to make sure your base is identifiable from everybody else's base. So you might want to give it a unique ID. You can also save the base station settings to the file. So if you set up a base on a known file, you can do all the configuration and then save those configurations to a file, which then next time you just load that file and you don't have to go through it all again. Alright, so the base station is now set up. It's reading GPS from the satellite and broadcasting its position over the UHF radio. However, nothing is listening. Now I have to configure the rover. So again, I specify the manufacturer. Actually, the base station and rover setups are very similar. Specify Bluetooth communication, right? And I always walk around and look, so you can see here that the Bluetooth light is blinking blue. That means we're in communication. Again, I would measure the antenna height, right? And there are actually two ways to measure the antenna height: vertical and slant. Vertical is if you know the plumb vertical distance from the bottom of your receiver to the mount. Right? In this case, this is a fixed 2-meter pole, so I can tell it it's 2 meters vertical. If I actually had to measure this, right, I'd want to do a slant measurement. So a slant measurement, Ali, you grab me the measuring tape. If you choose to enter the measurement as slant, it knows that this particular make and model of GPS is going to be measured from these 2 points right here. These are called the measuring points, so some people refer to them as the ears of the GPS. So that has a place where you can hook in your measuring tape and actually measure all the way down to the point the exact antenna height. And you notice it's called slant because we're kind of measuring at a slant from out here down to the tip of the point. So when you enter a slant measurement, it uses the preloaded specifications of this particular receiver to adjust that height to exactly what it should be. So I'm going to leave it as 2 meters vertical. And now I'm going to configure the RTK. So since these two are identical receivers, either one of these could be used as the base or rover. So I want to use the same internal NL400 microhard radio. Right, so that's just the UHF radio associated with this particular model of GPS. And I want to configure the radio to make sure that it's listening on the same frequency and the same message type. Now, a lot of times when you set up the rover, they've said, they've defaulted the message type to any. So as long as your base ID matches up, the rover figures out what the message is. So it's kind of taken one configuration step out of it. So I click the ever-present green check mark, and now I'm ready to survey. So in ServCE and ServPC are essentially the same software. One's designed to run on Windows Mobile, one's designed to run on Windows 10. So I kind of still say ServCE, even though I'm using ServPC. So in ServCE, you go to store points, and that basically gives you a map and allows you to start collecting points. Now, unfortunately, or fortunately, I can't show you autonomous, float, and fixed because I'm already fixed. Right, so this is relatively good GPS conditions. Okay, so now I have a standard deviation of 0.012 feet horizontally, so 12 1,000ths of a foot horizontally, and 0.031 vertical. have a position dilution of precision of 2.22, right? Typically, I've heard that you want that to be less than 6. I've also heard that you want it to be less than 4. I don't think I've ever heard it you want it to be less than 2, but typically around 2 is what you get for your PDOT, we call it. And it's giving me my northing and easting and my actual orthometric elevation, right? So my survey elevation above the data, because there's already a geoid model put in here from what I did in the office. All right, so let's collect some points. Who wants to go first? I'm gonna hold these down, and so we're just gonna hold it while we collect these points. All right, I'm just gonna hold them down and Velcro it in, and so we can move pretty quick and everybody can get a chance to get it. All right. So up at the top here, we have 4 letters, S-A-O-C. S stands for survey or store point. That's the one we press when we're ready to actually store the point. So the objective here is to get on the point, and for the purposes of this demonstration, don't necessarily worry about the penetration of the spike into the ground. Right? Just take a point and just be cognizant that if you were doing this for real, you'd want to have a topo shoe on there if you were in a grassy area. So you want to get the bubble right in the center of the bullseye, and then click store, and try to hold it as still as possible. And you hear that happy sound? That means the point is stored, and I have this set up today to show some diagnostic information. So this is telling me that I got 6 out of 6 valid readings. So I set it up to collect 6 points. All 6 of those had standard deviations that met my criteria. They were all taken under a fixed mode, and it gives me my position, right? So we're at elevation roughly 69.781 feet right now. Then I click the check mark, and I get another happy sound that stores the point. And now that point is displayed on my screen. Okay? So, Shiblu, give it a shot. Okay, so take it, put it on any point you find interesting. That one will do. Alright, so what I do is I hold the rod with my left hand, and then, actually, you know what? You should probably use the tripod. This is you're doing this for the first time, so let me kick these out. And since you did the other one, this should be similar for you, except this time you're adjusting with your thumbs. Right? So you want to squeeze those, drop the legs. I'm sorry, try to get a big base. Right, squeeze the buttons. There you go. See, these drop out. And then now squeeze the buttons and shift it around so your bubbles in the center. So you want to push it down. Yeah, there you go. Make sure you're always squeezing. Otherwise, you'll pick the legs up, and that's no good. That's good enough. All right, it's a good way to work on your grip strength. Okay, now when you're ready, tap the S button with the stylus or your finger. So see now it's reading 1 of 6, 2 of 6, and it's telling you the valid, and then also your standard deviations in all your directions. So you got 6 out of 6. Now click the green check mark. There you go. All right, so let's run through. Everybody get a turn. Who's next? What's your name? All right. So pick everything up, right, and just move the whole system to another point somewhere. And feel free to get on the sidewalk too. That's perfectly permissible. All right, now you want to set it down. So all 2 points, grab both of these like this, and squeeze hard with your thumbs. And now adjust it so that bubble is right in the middle. Remember, if you're moving it, you must be squeezing as hard as you can. And actually, the skill in this is how to let go softly, such that you don't jar it out of plumb and level. Right, so that's good. Now press the S button at the top to store this point. All right, so these are your standard deviations you're getting. So those are very good. And then you store the point. All right, so everybody run through once, and then we'll, feel free to spread out. You know what I mean? If we were doing a national project, then we'd want to get maybe the elevations of those stormwater inlets. Right around here. Maybe some sidewalk elevations. Because when we're done, we're going to export these data, and then I'm going to go put up GIS on the projector, and we'll actually see these points.